Hello everybody, my name is Joe Villarreal and today I'm going to be talking about the COVID-19 epidemic. So I'm going to be talking about giving information about what COVID-19 is, its structure, and basically how to prevent it, its genomes, symptoms, and things like that. So let's get started. So what are coronaviruses? So coronaviruses are enveloped, positive, single-stranded large RNA viruses that basically infect humans and other wide ranges of animals. They are major pathogens that attack the human respiratory system. They're named for their crown-like spikes on their surface, and they're divided into 4 groups, which is basically alpha, beta, gamma, and delta groups. Corona is Latin for crown, which is the name coronavirus. So the alpha and beta coronaviruses apparently originate from mammals, particularly bats, while the gamma and the delta viruses originate from pigs and birds. So coronavirus shape and structure. So coronavirus virions, which is the shape or the body of the virus, are spherical with a diameter of 125 nanometers. The virus also has a prominent feature of club-shaped projections that come off the surface of the virus. These projections give an appearance of a solar corona. Coronaviruses also have a helically symmetrical nuclear capsid, which within those nuclear capsid in the center of the virus is nucleic acid and genetic material of the virus. The virus has 4 structural proteins, which is spike, membrane, envelope, and nucleocapsid. The S protein is used for the virus to initially give attachments to give an attachment to the cell. It usually wants to initially help attach and attack the infected cell. So this image here is of a coronavirus. You can see the solar coronas protruding off of this virus. And this is from the Smithsonian Magazine. So then what is COVID-19? So the coronavirus of 2019 is known as COVID-19. The disease is known as severe acute respiratory syndrome, coronavirus 2, or SARS-CoV-2. It's a respiratory illness that can spread from person to person. The name is abbreviated as COVID-19. So CO is for corona, VI is for virus, and D is for disease. The virus is referred to as a novel or new coronavirus because the virus causing COVID is basically not the same as other coronaviruses seen in humans in the past. The illnesses from the coronavirus seen in the past were mild illnesses such as the common cold. COVID-19 belongs to the beta coronavirus family, which can basically infect humans and cause severe disease and even death. So the origin of COVID-19. So the outbreak of COVID-19 occurred at the end of 2019 in the Hunan seafood market in Wuhan, China, and spread across the world. And the Hunan seafood market was known to have sold foods such as frogs, bats, birds, rabbits, and even marmots and snakes. So the outbreak of the coronavirus in Wuhan killed about 1,800 individuals and infected 70,000 individuals within the first 50 days of the pandemic. The WHO Emergency Committee then enacted by addressing a global health emergency based on the rising cases of COVID-19 in China and in other countries. Bats were indicated to be the primary suspect or reservoir for this sickness or this disease, basically, according to these studies. So in 2013, Rhinoceros bats were found to have anti-SARS-CoV antibodies, which suggested that they were the source of viral replication, that bats were. And then in 2012, the Middle East Respiratory Syndrome coronavirus, MERS, emerged in Saudi Arabia and belongs to the beta family. It was followed by those that this coronavirus was detected in 2 types of bats, which is Pipistrellus and Pemiotis. This indicated that bats are the key host and transmitters of this virus. Followed by this, genomic similarity was found between the novel coronavirus COVID-19, and SARS-like bat viruses such as MERS coronavirus, making bats the primary reservoir for COVID-19. This image is the Hunan seafood market in Wuhan, China, where the virus first came to play, basically where the outbreak occurred. So genomic variation in COVID-19. So the genome of SARS-CoV-2 has been reported to be about 80% similar to the human coronavirus in 2003. SARS-2 also is close to a group of SARS coronaviruses. It has a fluctuation in the number of amino acids in its proteins 8B and 3C. These proteins basically give a higher replication rate and efficiency in cells to infect. The spike glycoprotein on the COVID-19 is a mixture of bat SARS-CoV and an unknown beta-CoV. The glycoprotein spikes promote entry into the cells and are what the antibodies try to target. The virus can enter the body through the nose, mouth, and even the eyes. This image is the image of a coronavirus. You can see that it's spherical. You can see the club-like protrusions coming out of the virus, the spike glycoproteins. You can see the nucleocapsid here in the center, the RNA and N proteins, and your envelope proteins. So gene mutations in the coronavirus. So from its 30,000 base pair genome, SARS-CoV-2 accumulates an average of about 1 to 2 mutations per month, which is about 2 to 4 times slower than the flu. So researchers can observe these mutations and make phylogenetic trees to basically look at different COVID-19 cases to see how the virus is spreading. They can look at basically how the genome variation is. They can look at whether or not there are different strains of the viruses. At this moment, they said the virus is too new for any genomic changes to be seen. All the genomic variations are too similar, and that there's only been a handful of mutations that have been identified. So how does COVID-19 affect an individual? So once it enters the body, it uses its oily membrane and fuses that with the cell membrane that it's trying to infect. Followed by this, it releases a genetic material of RNA. Now the RNA is put into the cell. The cell thinks that the RNA is its own, so the immune system doesn't try to act. It stays at bay. So then the cell continues to make its own proteins, and the virus begins to make copies of itself and replicates within the cell. So new copies of the virus will be assembled and will assemble at the outer edge of the cell and will be ready to leave the cell and infect other cells in the body. The immune system, when it decides to respond, can overreact and tend to attack lung cells, and because they attack the lung cells, the lungs can fill up with fluid and dying lung cells, which can make it hard for an individual to breathe, and this can lead to respiratory failure within a person. So symptoms and medical complications of COVID-19 in humans. So the initial sign of COVID-19, which leads to case detection, is pneumonia. So other recent cases that led to diagnosis of COVID-19 have been gastrointestinal symptoms and asymptomatic infections as well. In symptomatic patients, clinical manifestations or symptoms usually start less than a week. Symptomatic or symptoms include basically to be diagnosed for COVID-19 are cough, nasal congestion, fatigue, and other signs of upper respiratory tract infections. So basically prominent signs of viral pneumonia include decreased oxygen saturation, blood gas deviation, and you can see abnormalities between your chest through x-rays or other visual imaging techniques as well. So when it comes to symptoms, some individuals with COVID-19 have no symptoms at all, so they're asymptomatic, while others become so sick or they become so dangerously ill to the point where they require mechanical assistance to breathe from either a ventilator, and it needs to be there to keep them alive. This image here shows primary symptoms of COVID-19 and where they can be located on the body. So how can changes in diet help? So a healthy diet can already reduce obesity, diabetes, heart failure, stroke, and other diseases. So another way to combat the coronavirus in the future is basically controlling the defenses within yourself, our immune system. So with a healthy diet, we can control trillions of microbes, or basically that are in our gut. So our gut microbiome plays an essential role in how our body immune system works and fights infections. So eating diverse amounts of food and limiting processed foods that we can eat can give our gut biome a variety of diversity that just keeps our immune system healthy and ready to fight off any disease. This image here shows how microbes help our immune system. They provide a barrier to invasive microbes, and they enhance our immune system. Along with this, bacteria in the gut plays a role in the synthesis of vitamins C, B, and K as well. And they also help in the absorption of calcium and iron and help with metabolic rates. So what are some responsibilities as a global citizen? So I think as a global citizen, people need to support each other in any way possible. If groups are close-knit with each other and they're close with their communities, they need to be able to raise awareness about the current situation. They need to be able to give out information about what's going on without causing panic. They need to be able to also provide services to those in need if they need it, and possibly even try to work with their local government to get through this pandemic together. I think individuals and families can also volunteer with organized groups to donate stuff to people in need. They can donate necessities, toiletries, canned foods, clothes, disinfectants to those that can't afford them or don't have access to them, because there might not be none anymore in any stores. So that's what I think people as global citizens can do. I think they should also practice coughing and sneezing into their elbows, basically practicing social distancing and having good hand washing techniques and good personal hygiene. So some suggestions to prevent the excess spreading of COVID-19. I think in my hometown of Laredo, Texas, we have done excellent measures to prevent the excess spreading of COVID-19. So my hometown is a border city, and it's one of the largest, busiest trade ports in Texas. It comprises half of all commerce along Texas's 11 land ports. So some measures that Laredo took when we first heard about the epidemic was shut down the border crossing between Laredo and Mexico, which limits the spread of disease, obviously. So I think that was very helpful. Along with this, we included strict stay-at-home orders, and along social distancing was implemented, along with curfews in late March from 10 p.m. to 5 a.m. for these things to come into effect. Along with this, a $1,000 fine would be issued if people left their homes without wearing a face mask to cover their mouth and noses, because the mouth and nose is where COVID-19 usually can enter the body. So this helped with limiting the spread of disease in our hometown. Along with our border checkpoints, they issued to where truck drivers could no longer get off their vehicles and they can no longer handle the merchandise. I think that was helpful in limiting human-to-human interaction within delivering merchandise to limit the spread of the virus. I think one thing that I would have tried to have done differently that China did not do was try to address the situation right away instead of seeing it as something minor and trying to solve it and isolate people who had that virus before it grew out into something major and exploded like it did today in what we're living in currently. So I think some propositions to suppress future virus outbreaks. I think obviously coughing and sneezing into your arm is a good practice, along with having good hygiene and hand washing to limit the spread of germs. I think since the virus is a foodborne outbreak, preventing foodborne outbreaks should be done. So produce farmers need to pick up they need to practice safe agricultural practices for processing foods, such as pasteurization, canning foods, cooking, even irradiation can be done to kill pathogens during food processing. I think that for distributing or processing foods, that restaurant workers, they should continue learning about food safety and sanitation, because they handle food in public places in public places that people eat. So if they are able to handle the food safely, they can lower the amount of contamination and the risk of a foodborne illness to break out again. I think that public places should also have clean and proper hand washing facilities, along with procedures of how to do it. This can limit the spread of germs in public places, such as in malls and food courts. I think that one proposition should be for food workers and other workers in general, that they should be encouraged to not go to work when they're sick, so they can limit the spread of sickness to co-workers, and so the co-workers won't give it to their families. This limits the spread of the disease in their communities. I think that food education should be done, food safety education should be done for consumers, because consumers should know what they're putting in their bodies, what they should eat, how they should safely handle their food, what they shouldn't eat at all, and basically what contaminated food could be, and basically just know the proper safety information for handling your food, so you don't so you won't get a foodborne illness and you won't spread it to any others in your area. So at this point, this concludes my presentation. I thank you all for listening to it. Thank you. Be safe. Make sure to wash your hands. And these are my reference slides. Thank you.